conservation of mass. This is very simple. The formation of compounds of elements is based on the following 5 basic laws. The first is law of conservation of mass, then definite proportions or constant composition. Then we have law of multiple proportions, Gay-Lussac's law of gaseous volumes, and Avogadro's law. So under law of conservation of mass, the first question that can be asked is who proposed it? It was proposed by Antoine Lavoisier. Please learn this name. The law states matter can neither be created nor be destroyed. So an illustration of the law, if we consider carbon and oxygen to give carbon dioxide, if we talk about this reaction, then what are the elements required? We require carbon and oxygen, and the chemical reaction would be as given above, carbon plus oxygen to give carbon dioxide, right? If we look at it by masses, atomic weights, then you know carbon has atomic weight 12 gram, oxygen has atomic mass 16, but since it is diatomic, its mass is going to become 32. So 12 gram and 32 gram carbon and oxygen are reacting to form carbon dioxide. And what is the molecular mass of carbon dioxide? It is 44 gram. So what do we observe from this example? That the total mass of the reactants is equal to that of the product. So matter can neither be destroyed nor be created. Whatever amount of matter we take as the reactants, the entire mass goes in the form of products. This is law of conservation of mass proposed by Lavoisier. Mass of reactants is always equal to mass of products. Then we have an example. So you can be asked an example in exams. For example, 10 gram of calcium carbonate on heating gave 4.4 gram of carbon dioxide and 5.6 gram of calcium oxide. So show that these are in agreement with the law of conservation of mass. You're simply going to write the reaction. Mass of calcium carbonate is 10 gram, mass of carbon dioxide is 4.4 and calcium oxide is 5.6. So if you add the mass of the products, it comes out to be equal to mass of the reactant. The reactant here is calcium carbonate, 10 gram, and the mass of the two products is also total 10 gram. Hence, law of conservation of mass is confirmed. So, which of the following reactions is not correct according to the law of conservation of mass? So, another question could have been asked here. The question could have been, based on what is given here, you could have been asked a question stating um, which law is used to balance chemical equations. So what will our answer be? We use law of conservation of mass to balance chemical equations, right? Law of conservation of mass is used. Hence, in which out of these equations balancing has not been done? In equation B. So equation B is not correct according to law of conservation of mass. All other equations are balanced, which means number of atoms of each kind on both sides of the equation are the same. You can check each of these. Only in equation B, balancing is not done. This side we have 3 carbons, but this side is only 1 carbon. So balancing is missing. Hence, the right answer to this question is B part. Next is law of definite proportions. So again, to begin with, law of definite proportions, let us first define. First, they can ask you definition, then they can ask you who proposed the law. The law of definite proportions or definite composition states, just look at this. We have water coming from different sources, lake, ocean, or water produced in a chemical reaction in a lab. Any source, the formula of water is always H2, and by weight, it always contains 2 gram of hydrogen and 16 gram of oxygen, which when we calculate by weight percentage, it comes out to be 11.11% hydrogen and 88.89% of oxygen, sorry, by weight, right? So what does the law say? Any pure compound, in this case we are assuming water, always contains the same element in a definite proportion by weight. So irrespective of the source, a pure compound always contains the same element in the same definite proportion by mass, irrespective of the source or the method of preparation. Clear? This is law of definite proportion. So definition is important from your examination point of view, and it was proposed by Joseph Proust. Joseph Proust. A given compound always contains exactly the same proportion of elements by weight. Any compound we can take. So pure water obtained from different sources such as river, well, sea, etc. always contains hydrogen and oxygen in the same proportion. As an example, 1.375 gram of cupric oxide, 1.37 of cupric oxide, the formula is CuO, was reduced by heating in a current of hydrogen, and the weight of copper that remained was this much. That means this much of copper oxide gave this much of copper. This is what is of interest to us. This was done by one particular kind of experiment. In another experiment, this much of copper was dissolved in nitric acid, and the resulting copper nitrate converted to copper oxide by ignition. So weight of copper oxide was this much. So what is of importance to us? For us, what is important is 1.375 gram copper oxide is giving 1.098 gram of copper. This is experiment 1. And in experiment 2, 1.179 gram of, 1.476 gram of copper oxide contains 1.179 gram of copper. Read this line, this much of copper oxide contains this much of copper. This is our first observation. Second says this much of copper oxide was formed from this much of copper. So two sets of experiments given to us. They say illustrate the law of constant composition. What are you going to do? In each of the two cases, you will find out the weight of oxygen by subtracting total weight minus copper. You'll get percentage of oxygen you can calculate. This was weight of copper oxide. This was weight of copper. We subtracted and we got weight of oxygen. So what is the percentage of oxygen? Weight of oxygen upon total weight of copper oxide into 100. This is in one observation. So we get 20.14% of oxygen in the first case. Right? Now, in the second experiment, again we are going to calculate by subtracting. We'll calculate oxygen. And then percentage of oxygen can be calculated. It is found to be the same. So what do we conclude? Irrespective of the two different experimental methods, the method used for producing copper oxide, percentage of oxygen is found to be same in both the cases. So law of constant composition is proved. The third one is law of multiple proportions proposed by John Dalton. So according to this law, if two elements, now this law is the most important from examination point of view. You can be asked this has maximum chance of being asked in an exam, and this is generally asked as define and illustrate. So according to this law, when two elements combine, very important, two elements, you cannot write two or more here. Please note this. When two elements combine to form two or more than two compounds, compounds can be any number. Two elements combine to form two or more than two compounds, then masses of one of the elements that combine with the fixed mass of the other are in the ratio of small whole numbers. Right? This is the law. How do we illustrate the law? Let us say we take two elements, hydrogen and oxygen, two different compounds, water and H2O2. We know in this case, 2:16 is the combination. 2 gram of hydrogen is combining with 16 parts of oxygen. Here 2 parts of hydrogen is combining with 32 parts of oxygen. So if I keep the mass of hydrogen fixed in both, so when two elements combine to form two or more compounds, then mass of one of the elements, let us say oxygen in this case, which combines with the fixed mate of the other, that is hydrogen, in the two different compounds, should be in a simple fixed whole number ratio, which in this case is 1:2. Hence, the law of multiple proportions is verified. Okay, so you can quote this example, or we can have another example quoted. Let us say I'm talking about nitrogen oxides. I'm talking about N2O, NO, NO2, N2O5. Let us say I'm talking about these four oxides of nitrogen, and let us see if law of multiple proportions is verified or not. In this case, it's 28:16, 14:16, 14:32, and 28:16 into 5 is 80. So what do? We convert each of these to 14. 14:8. This is already 14:16, 14:32, and this is 14:40. What do? I calculate the proportion in which each of these is combining. And now finally, I will take this as a fixed mass. The mass of oxygen that combines with a fixed mass of nitrogen in the different compounds. We took two elements, nitrogen and oxygen, made the mass of one of the elements, that is nitrogen, fixed in all these compounds. The ratio of oxygen in these different compounds is found to be this, which is 1:2, ratio 4, ratio 5, which is a simple whole number ratio. Hence, the law is illustrated. This is law of multiple proportions. So, a probable question for exams: which of the following statements indicates that the law of multiple proportion is being followed? Sample of carbon dioxide taken from any source will always have carbon and oxygen in the ratio 1:2. Does this obey law of multiple proportion? No. Which law is this governing? Law of definite proportions. Next is carbon forms two oxides, namely carbon dioxide and carbon monoxide, where masses of oxygen which combine with fixed mass of carbon are in the simple ratio 2:1. Let us check. Carbon dioxide, carbon monoxide, two compounds of elements carbon and oxygen. This is 12:32. This is 12:16. They say fix the masses of oxygen. How can I fix the mass of oxygen? I make this 16 and I make this 6. I divide both by 2. So if I keep the mass of oxygen fixed this time, any one of the two elements can be kept fixed. I find carbon is in the ratio of 6:12, that is 1:2. So I repeat this. It says carbon forms two oxides where masses of oxygen with combined with the fixed mass of carbon are in the simple ratio 2:1. It's actually 1:2 ratio. Okay, but let us see what the next one says. When magnesium burns in oxygen, so when magnesium burns in oxygen, the amount of magnesium taken for the reaction is equal to amount of magnesium in magnesium oxide. Which law is this? This is law of conservation of mass. And at constant temperature and pressure, 200 ml of hydrogen will combine with 100 ml of oxygen to produce 200 ml of water vapor. Which law is this? This is, if I'm taking 200 ml of oxygen, obviously for 1 mole of hydrogen, I need half a mole of oxygen, which means 200 ml of hydrogen would need only 100 ml of oxygen and produce 200 ml of water vapor. under similar conditions, right? Which law is this? This is Gay-Lussac's law of combining volumes. Hence, which out of these is indicating law of multiple proportions? The right answer is B part. So we have another example. Hydrogen and oxygen are known to form two compounds. Hydrogen content in one of these is 5.93, while in the other it is 11.2. So two compounds of hydrogen and oxygen, and in both the content of hydrogen is given. They say illustrate the law of multiple proportions. So you can pause, try it on your own, and then check the answer. So how do we solve? In the first compound, hydrogen is 5.93, which means oxygen is going to be 100 minus 5.93. So we get it to be 94.07. In the next case, hydrogen is given. So again, we calculate oxygen by subtracting. We get 88.8. So what do we do? In the first compound, number of parts by weight of oxygen that combine with one part of hydrogen will be this much. Why? Because 94% of oxygen for 5.93 of hydrogen. So I explain this. We got 94.0 parts of oxygen for 5.93 parts of hydrogen. Fine. So 5.93 H for 94.07 O. Parts means you can put the same unit both sides, any unit. So 1 gram of hydrogen is going to combine with 94.07 upon 5.93 parts of oxygen. We get this. Similarly, in the second case also, we can calculate the same thing. In the second case, I can say 11.2 parts of hydrogen combines with 88.8 parts of oxygen, which means one part is going to combine with 88.88 upon 11.2. Right? So I'll calculate this, and I'll calculate the ratio of these two. If it comes out to be a simple whole number ratio, that means the law is verified. So let us look at this. Okay, 7.9 parts. So what do we get? We get with the fixed mass, that is one part by mass of hydrogen. In the two cases, we get this much of oxygen and this much of oxygen, which is in the ratio of 2:1, which means the law of multiple proportions is verified. So this is one way of asking a question. And then what are the other questions that can be asked based on these laws? You can be asked to define each law, illustrate each law with an example. And I told you the most important one is generally law of multiple proportions. Okay, any of these can be asked, but you have a tendency to make mistakes in multiple proportions, so learn that well. Who proposed the law of conservation of mass? Lavoisier. Who proposed law of definite proportions? Who proposed law of multiple proportions? So Proust and Dalton, you must learn these. We've just covered it in the. So the next one is Gay-Lussac's law of combining volumes. It states that when gases react to form other gases, the volume of the reactants and products are in a simple whole number ratio, right? So remember, this is only applicable to gases. Both reactants as well as products should be gas. Only then this is applicable. Second requirement is this law applies only when the gases are at the same temperature and pressure. So according to this equation, two volumes of hydrogen gas combine with one volume of chlorine to form two volumes of HCl. And you know the molar volume at NTP. Molar volume at NTP or STP, that is the present standard conditions, which is 1 bar and 273 Kelvin, is 22.7 liter. So if I want to apply that concept, the 2 into 22.7 liter at these conditions will combine with 22.7 liter of this to form 2 into 22.7 liter of this, which means if we cancel off this common number, we get the ratio as 2 is to 1 is to 2. And this is what the law says, that the gases combine in simple whole number ratio. The next law is Avogadro's law. What does Avogadro's law state? It states a total number of atoms or molecules of a gas, that is the amount of gaseous substance, is directly proportional to the volume occupied by the gas at constant temperature and pressure. Okay, so volume occupied is directly proportional to number of moles. N is the number of moles, and since number of moles are directly proportional to number of molecules, so we can say V is directly proportional to N, also directly proportional to N. Volume is also directly proportional to number of molecules. That means equal volumes of all gases will have equal number of molecules. So equal volume of all gases at similar conditions of temperature and pressure have equal number of moles and hence molecules. This is what Avogadro's law says. So 1 mole of every gas at 1 bar and 273 Kelvin will occupy a volume of 22.7 liter and would have Avogadro number of molecules. And what is Avogadro number? 6.022 into 10 to the power 23, which also means I can take an example, 1 mole of oxygen gas or 1 mole of ammonia gas or nitrogen gas or any gas is going to have 6.022 into 10 to the power 23 molecules. This is what Avogadro's law states. So I hope these many topics are clear, children. All the questions that are possibly asked at your school level, I have covered in this. Hope you have a good learning session. Please do comment and let me know whether you liked it or not, whether it was useful or not. And if you want it in any other way, more elaborate or less elaborate or faster or just the questions, please feel free to share. I would love to help. Thank you. And do like, share, and subscribe to anybody you feel this can be helpful for. And this also helps uh, more reach of this video and more motivation for me to work further. I really want to reach to more number of students. So please feel free to share how you feel you can be helped. Thank you and God bless you all. Have a happy